Hello everyone, in this video we are going to learn about binomial expression. So firstly we need to learn what is Pascal's triangle. Now let us consider a plus b to the power of n for n equals to 0, 1, 2, 3 and 4. You can see I have write down all of them. So a plus b to the power of 0 equals to 1, a plus 1 to the power of 1, that is a plus b, and so on. Now we only focus on the coefficient of each term. So in the first row, we have a plus b to the power of 0, the coefficient is 1. And for the second row, a plus b to the power of 1, we have the coefficient 1 for the first term, and the second term, that is also 1. Next row, we have a square that the coefficient is 1. For 2ab, the coefficient is 2. For b squared, the coefficient is 1. Similarly, let us see this next row. So a cubed, that is the coefficient is 1. 3a squared b, that is 3. And 3ab squared, the coefficient is 3. For the b cubed, the coefficient is 1. For a to the power of 4, the coefficient is 1. For 4a cubed b is 4, the coefficient is 4. For 6 times a squared b squared, the coefficient is 6. And for 4ab cubed, the coefficient is 4. For the b to the power of 4, the coefficient is 1. Now let us just see the coefficient. We can find that. We can add in pairs of numbers to find the numbers on the next row. So let us see, 1 plus 1 equals to 2. And 1 plus 2 equals to 3 for the next row. And 2 plus 1 equals to 3. And then for the next row, the 4 comes from 1 plus 3. And the 6 comes from 3 plus 3. And this 4 comes from 3 plus 1. So we can see that you add adjacent pairs of numbers to find the numbers on the next row. This is what we called the Pascal's triangle. So it is a pattern for the coefficient in the expression. So we can see that the n plus 1th row of Pascal's triangle gives the coefficient in the expansion of a plus b to the power of n. So you can see that here is the first row, here is second, here is third, here is fourth, here is fifth. So in the fifth row, you have the coefficient of the expansion of a plus b to the power of 4. So you can get the rule that the n plus 1th row of Pascal's triangle gives the coefficients in the expansion of a plus b to the power of n. Now, for example, let us see a plus b to the power of 5. What's the coefficient? So we firstly get the 1 of that. And then we have 1 plus 4, that is 5. 4 plus 6, that is 10. 6 plus 4, that is 10. And 4 plus 1 is 5. And then you have another 1. You can double check it to use a calculator to see it. So now you know the Pascal's triangle. Now let's move on to learn about factorial notation. So you can see that the Pascal's triangle is really useful to identify the coefficient of the expansion. But when you're expanding binomial expression with a larger indices, I think the Pascal's triangle is not so convenient for you. Well, this time we will learn to use a factorial notation. That is n factorial What means? It means that n factorial equals to n times n minus 1 times n minus 2 times n minus 3 times so on times 3 times 2 times 1. For example, we have 3 factorial that equals to 3 times 2 times 1. 10 factorial equals to 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. After you know in the definition of the factorial notation, now I will tell you there is another way to find the entrance in Pascal's triangle, that is n choose r. That equals to, you can write like that, nr, which means equals to n factorial over r factorial times n minus r factorial. We usually say that n choose r. So what is the relationship for that with the Pascal's triangle? So the rth entry in the nth row of Pascal triangle is n minus 1 choose r minus 1 equals to n minus 1 r minus 1. So what you have n minus 1 factorial over r minus 1 factorial times n minus 1 minus r minus 1 factorial. You can see this simple in your calculator. You need to first press the shift and then plus the divided symbol in the calculator. Now let's look at some example to use a factorial notation to calculate. So the example asks you to, without using a calculator, to work out these questions. So by the definition of the factorial notation, 10 factorial equals to 10 times 9 times 8 times 7 and so on times 3 times 2 times 1. For the 8 factorial, what we have 8 times 7 times so on times 3 times 2 times 1. We can see that there is common factor. Start from the 8 to the 1. So 8 times 7 times 6 and so on times 1 is a common factor. So we can cancel them. What we left 10 times 9, that equals to 90. Now move on to see the second question. So 9, 6, it means that 9 choose 6. We can write that 9 choose 6, which means equals to 9 factorial over 6 factorial times 9 minus 6 factorial equals to 9 times 8 times 7 times 6 and so on times 2 times 1 over 6 times 5 times 4 times so on times 2 times 1. So that is for the 6 factorial. And 9 minus 6 is 3. And the 3 factorial, that is 3 times 2 times 1. We can see the common factor is start from the 6 times 5 times 4 and so on to the 1. So we can cancel this part. What we left? We left 9 times 8 times 7 over 3 times 2 times 1. We can now simplify it. So 2, that will be 4. 3, that will be 3. So what we have? We have 3 times 4 times 7 over 1. That is 12 times 10. 12 times 7. That is 84. Now for the third question, we have 6 choose 4. That equals to 6 factorial over 4 factorial times 6 minus 4 factorial equals to 6 times 5 times 4 and so on times 3 times 2, so times 1 over 4 times 3 times so on times 1 times 6 minus 4, that is 2, so 2 factorial equals to 2 times 1. We can see the repeated part is 4 times 2 the 1, so we can cancel them. And what we left 6 times 5 over 2 times 1, and simplify it, so 2, 3, what do we have? We have 15. Now let's move on to see the second question. Given that 49 choose 15 equals to 49 factorial over 15 factorial a factorial times a factorial. Write down the value of a. So remember that the formula of the n choose r equals to n factorial over r factorial times n minus r factorial. We have n equals to 49, r equals to 15, and n minus r equals to a. So a equals to 49 minus 15, that equals to 34. So we find the value of a. Now let's move on to see another example. So here we have 27 choose b equals to 27 factorial over b factorial times 9 factorial. Still recall that n choose r equals to n factorial over r factorial times n minus r factorial equals to 27 factorial over b factorial 9 factorial. Which means n equals to 27. Since the value of b is missing r, so r equals to b. What we left n minus r equals to 9. And substitute 27 into n minus r, that is 27 minus r equals to 9. So r equals to 27 minus 9, that is 18. So we find the value of the b equals to 18. Now we have learned that the Pascal's triangle and the factorial notation is used to find the coefficient of each term, so we can write down the whole binomial expansion. That is a plus b to the power of n equals to a to the power of n plus n choose 1, a to the power of n minus 1 times b plus n choose 2 times a to the power of n minus 2 b squared plus so on plus n choose r times a to the power of n minus r times b to the power of r plus so on plus b to the power of n, where n belongs to the natural number, and n choose r equals to n factorial over r factorial times n minus r factorial. So here is a binomial expansion. Let's look at some example question. So the question asks you to find the first three terms in ascending powers of x of the binomial expansion. Be aware of that in ascending powers of x, so you need to write down like x to the power of 1 and then to the power of x squared and then to x cubed, such like that. So the indices is increasing. So we have the binomial expansion 2 minus 3x to the power of 5. We write down that. So 2 minus 3x to the power of 5. So first, we know that the a is 2. So a plus b to the power of n. Remember that. So a is 2, b is minus 3x. So we write down the first one is a to the power of n, that is 2 to the power of 5. So 2 to the power of 5. And then what we have the n choose 1 factorial times a to the power of n minus 1 times b. We write down that plus n is 5, so 5 choose 1 times 2, 5 minus 1 to the power, that is to the power of 4, b is minus 3x. And for the third term, we have n choose 2 times a to the power of n minus 2 b squared. So in this expansion, what we have, n is 5, that is 5 choose 2. So a to the power of 5 minus 2, that is 3. So it's 2 to the power of 3. b is minus 3x. So we write down that is minus 3x to the power of 2. Since the question only asks you to find the first three terms, so you only need to write down the three terms, but you also need to write down so on, because this is not the end of the expansion. now we rearrange that. So 2 to the power of 5, that is 32, plus 5, choose 1. You can use a calculator to calculate. It is 5. So 5 times 16 times minus 3x plus 5, choose 2. That is 10 times 8 times 9x squared plus so on equals to 32 minus 240x plus 720x squared. So we have done that question. Now let me give you another example, similar question. So in this question, it asks you to find the first 4 terms in ascending powers of x of the binomial expansion 1 plus 2x to the power of 6. So for the expansion a plus b to the power of n, we have a equals to 1, b equals to 2x, and n equals to 6. So we can write down that 1 plus 2x to the power of 6 equals to, so the first one is a to the power of n, that is 1 to the power of n, that is 1 to the power of 6. And the second term, that is n choose 1 times, n choose 1 times a to the power of n minus 1 times b. In this expansion, we have 6 choose 1 times 1 times to the power of 5 times 2x. For the third term, we have n choose 2 times a to the power of n minus 2 times b squared. So we have 6 choose 2 times 1 to the power of 6 minus 2, that is 4, times 2x to the power of 2. And the fourth term, what we have n choose 3 times a to the power of n minus 3 times b cubed. So we write down that plus 6 choose 3 times 1 to the power of 6 minus 3, that is 3, b, that is 2x, so times 2x cubed. So we have done the first 4 terms, and so on. Now we rearrange that. We have 1 plus 6 times 2x. You can use a calculator to calculate the factorial, to calculate 6 choose 1, 6 choose 2, and 6 choose 3. Or maybe you want to use the factorial notation. And then we have plus, so 6 choose 2, that is 15, times 1 times 4x squared, plus 6 choose 3, that is 20. And 1 cubed, that is 1, 2x cubed, that is 8x cubed, plus so on, equals to 1 plus 12x plus 60x squared plus 160x cubed, plus so on. So we have done this question. So we have done all the things. Here is a conclusion for this lesson. You know what is Pascal triangles, and now it is used to find the coefficient of the expansion. And n plus 1th row of Pascal's triangle gives the coefficient in the expansion of a plus b to the power of n. And we know what is factorial notation. So n factorial equals to n times n minus 1 times n minus 2, and so on, times 3 times 2 times 1. And then we can use the factorial notation to find entrance in Pascal's triangle. So that is the number of ways of choosing R atoms from a group of n terms. That we said is n choose R equals to n factorial over R factorial times n minus R factorial. And the R's entry in the nth row of Pascal's triangle is n minus 1 choose R minus 1. After you know how to find the coefficient of the expansion, you know how to write down the binomial expansion completely. So that is a plus b to the power of n equals to a to the power of n plus n choose 1 times a to the power of n minus 1 times b plus n choose 2 times a to the power of n minus 2 times b squared plus so on until b to the power of n. Okay, here is the end of the lesson. Hope you enjoyed. Thank you.